Overflows. Happy Friday. Quick note on the lab before we even get started into anything. So we've got our Kali lab here. I've created a folder called Buffer Overflows or BO. You can just put whatever. The other thing is I'm going to spin up right now our Punisher machine, and I want to show you some things with the lab. So it looks like Immunity Debugger had issues. I don't know if like we caused them to have issues, if they're just having issues this week or what's going on. So I'm going to walk through the process of setting up Immunity in a different way before we even get started with any of the lessons. That way, you guys have time to build that as I'm lecturing. So I'm going to come in and get into my machine. I'm just going to show you how I have it set up because I actually ran into the same issue. I had to rebuild this machine out. So we'll let this log in. But basically, what's happening is the Immunity Debugger website's not working. So in order to get Immunity, we need to go out and go and Google Immunity Debugger GitHub. Hey, good enough. This is a repository right here, this kbanla. If you click into it, and you can just download the code, download the zip, and bring it over. Or if you're very Git friendly, you can get just the 1.85. All right. So if you come in here, get the 1.85, download that, and extract that to your Windows machine, you should have some smooth sailing. So 1.85 right here is what I've got extracted. If you come into the tools part right here, we just go into tools. We have the command shell, PyShell. Actually, where is it? There's the Python installation is what we're looking for. You can install Python on your machine 2.7.1 right here from this installer. This will install Python and everything necessary to run Immunity Debugger. All right. And we also need to download and install Mona. So Mona is a tool that we're going to use. So if you just Google Mona Pi, you can grab this Corlan repository for Mona Pi. All we need is the Mona file. So you can just grab this file if you want, or again, you can download the zip and grab the file out of there. Once you grab the file, you need to make sure that you put that in the right place. So if you are using the Immunity Debugger from the GitHub, you just put that in your Py commands. So you just drop it right into the Py commands folder. You should see Mona. See, I downloaded Mona. It looks like actually they have Mona in here, so that's pretty nice. I didn't even realize that. So it looks like Mona might already be in here, so you can ignore me. But if you installed Immunity from the website, you need to go to your C drive, your program files x86, and then you just follow the steps from there. There should be an Immunity Debugger folder. And from within that Immunity Debugger folder, you would just find the Py commands and drop Mona in there as well. All right. So let's go ahead, get that set up if you need to. I know a lot of you were utilizing Discord to get it set up. I realize that there's some problems we've been having. So at least Immunity website's been having. It's always hard doing a live lesson like that when things go wrong, unfortunately. While we're at it, while I'm lecturing, I'm going to go ahead and give you guys the code. That's why you're all here. So I'm going to go ahead and just put the code on the screen. Today's code is going to be overflow my buffers. We are going to stop running the code at 12:11 Eastern Standard Time. Eastern Standard Time. Overflow my buffers. All right. If you don't know how to enter the code in by now, I have no help for you. If this is your first time watching, welcome. There's no point in entering an attendance code because you probably already missed it at this point. All right, we've got this set up. Let's go to the handy dandy PowerPoint lecture. Knock this out real quick, and then we'll start doing some buffer overflows, shall we? Okay, so let's talk about the anatomy of memory. So when we're doing buffer overflows, we're attacking memory. And within memory, we're attacking what's called the stack. So when we look at memory, we basically think of it as top and bottom. We've got the kernel up at the top, which is kind of just a bunch of ones. And then we can think of the text down at the bottom as a bunch of zeros. This isn't entirely true, but this is the best way to think about it. You can think of the kernel as like command line only or command only, right? Whereas text down here can be read-only code. This can be like a command line, read-only code. And when we dive into memory, we dive into the stack. In this instance, we're going to be doing what's called a stack-based buffer overflow. So what does that mean? Well, imagine that I clicked into the stack. We're diving in here, and now we're inside of the stack. This is really what's important, not so much the memory part. And this is a very high level overview, by the way. So within the stack, we have on a 32-bit register, we've got what's called an ESP, which is our stack pointer. We've got our EBP, which is our base pointer. So again, we can think of it as top and bottom. And then we've got this instruction pointer and return address. The instruction pointer is what's going to allow us to point to malicious code or point to a certain instruction, which our instruction is going to be malicious. So when we think about buffer space, we've got this buffer space in here. So imagine buffer space goes downwards, okay? So it flows downward. If as we put data into this buffer space, it's supposed to go downward and never pass the base pointer. So it looks something like this. If we're sending a bunch of A's off and we're properly sanitizing our buffer space, we're going to grow downward and we're never going to overflow. However, if we are vulnerable to a buffer overflow, what happens here is the A's actually just go right over the buffer space and get us down to past the EBP, past the EIP. And if we can get to this point of having this instruction pointer and we can control the instruction pointer, then we can be malicious with our code. So basically, what's going to happen here is we're going to overflow this buffer space and we're going to get to a point where we control what's called the EIP. We're going to use that to instruct malicious code, which is going to be a reverse shell in this instance, and we're going to get the reverse shell. All right. And come in here, steps to conduct a buffer overflow. We're just going to go through this really quick. We're going to do what's called fuzzing. So we're going to send a bunch of A's at a program and see if we can get it to crash. But we're going to do it in a random sense, and I'll show you the difference between that and other types of fuzzing that we're going to do. We're going to do what's called finding the offset, which is going to be looking at where the buffer overflow happens and where it stops before the EIP or that instruction pointer. Once we find the offset, we're going to overwrite the EIP with a bunch of B's instead of A's. We'll talk about why we do that. We're going to look for bad characters and the right module to overwrite, which this might not make any sense right now, but it will in a little bit. Then we're going to generate some shellcode and we're going to gain root after that. Easy breezy, beautiful cover girl. All right. And we are going to do spiking. Spiking is going to be part of the fuzzing. Don't worry. Don't worries. All right. So we've got our machines up and it's 12:11 now. So I'm going to go ahead and stop the attendance tracker. All right. So we're going to cover spiking first. Let's go ahead and talk about that. So in your Kali Linux machine and your Windows machine, let's go to the Windows machine first. Let's get something set up. So we come in here, we've got Vuln server. We're going to go ahead and looks like it deleted my vulnserver.exe. Let me see if it put it in here or not. No. Okay. So I'm going to put this back. First things first, go ahead and turn off your Windows Defender. So if you come in and type in Defender, go to Virus and Threat Protection. We're going to go to Manage Settings and turn off Real-Time Protection. All right. Make sure your real-time protection is turned off. I'm going to restore this back to the desktop and I'm going to grab Vuln server back. So I'm going to delete this and just put Vuln server back in here. So now what we're going to do is we can run this. So if we just run this the first time, run as administrator, you're going to see that we're running Vuln server. Vuln server is going to be vulnerable to software. Now, or vulnerable to attacks. It has many different attacks that we can do on it, but today we're just going to do a basic stack-based buffer overflow. Now, a lot of you get confused when we do buffer overflows. You say, well, why would I be doing this on a pen test? Or why would I be doing this on the victim's machine? And that's not really what we're doing. What we're doing is we're doing exploit development. Yes, we're attacking a victim machine, but in this instance, we're doing this in a lab environment. And that's the same thing we would be doing if we were doing exploit development. We would be doing this in a lab environment. So what we do is we try to find out if a certain software or code or whatever it might be is vulnerable. and then we try to exploit that. Then we develop that exploit, and then we use that to attack a machine. Okay, so don't think about this as, hey, we're doing this on a pen test. No, you would never do a buffer overflow like this on a pen test. You would never do exploit development on a pen test. However, you might run a buffer overflow on an engagement. So I think this lesson is still valid because it helps you understand what a buffer overflow is, what they look like, kind of why they happen, and it helps with generating shell code and understanding reverse shells, building off of last time in our lesson from last time as well. All right. So that's good from here. And then we're also going to come in here and just open up Immunity Debugger. All right. And just run that as admin. And up at the top, just go to File and Attach, and just attach your Vuln server that's in here. All right. I've got Zoom set up for all of these different areas. We're going to cover that, but you should be able to just navigate to File and attach Vuln server. I'm not going to zoom in on that. All right. So from here, we've got Vuln server running. We've got Immunity Debugger running. All right. Now what we're going to do is we're going to come in here and we're going to do what's called spiking. All right. So let's go to our Kali machine. Now, I've created a couple of files, and before I get into that, I'm going to netcat into my IP address. So you should come into your Windows machine and do an IP config, by the way. If you come to command, do an IP config. Okay, mine is running on 138.133. And I'm going to use that to connect to Vuln server. So this is what it looks like. I'm going to use netcat, similar to what we did in our last lesson, to make a connection. In this instance, I'm going to connect to our machine at 138.133. Now, Vuln server is running on port 9999 by default. So one other thing that we need to do, since we're attached, is we need to make sure we hit play on here, because I didn't hit play. So hit play in your Immunity Debugger if you've already loaded it into Immunity. And then we're going to go ahead and just make a connection. All right, it says, welcome to vulnerable server. Enter help for help. So we're just going to say help. And in here, we've got a bunch of different commands that we're looking at. You can see we've got stats, rtime, ltime, srun, trun, gmon, gdog, whatever. So we're going to look at these commands, and I'm going to show you how we can spike these commands and test them for buffer overflow capabilities. So we're going to grab the stats command, which is not vulnerable to the spiking. And then we're going to grab this trun command, which is going to be vulnerable to spiking. And just so you can see the difference. All right. So what we're going to do is we need to create a spike file so that way we can test out these commands. And when I say spiking, spiking is going to send a bunch of values, basically a bunch of A's you can think of, just a bunch of characters in random sizes. So it might send 100, then it might send 5,000, then it might send 20,000, then it might send 50. And what it's trying to do is it's trying to crash your server. We're trying to see if at some point we can send so much data that the buffer overflow happens and it crashes the server, and then we know we've got something vulnerable there, at least to denial of service. Then we're going to see if we can go back and actually write exploit code to get it to work. All right. So we're going to go ahead and exit here. And what we're going to do now is we're going to, I've got a couple of files here. So I'm going to go ahead and cat these out so you can see them. So I'm going to cat out the trun.spike, and I'm going to cat out the stats .spike, or the trun and stats. So go ahead and create a file with this in it. You're going to have the s underscore read line. I'll even make this a little bit bigger. Let me see, Control A. So I'm going to go ahead and make this a little bit bigger. And you can see we've got s underscore read line. And then we're going to provide it a string, which is going to be the trun with a space after it. And then it's going to have a string variable of 0. All this is going to do is say, hey, when I run this command, I want to run the trun command, or I want to run the stats command. And then after the space, I'm going to throw a bunch of random stuff at it. That's all we're going to do. We're going to throw a bunch of random characters at it and just see if we can break it. All right. So again, create two files, one with s underscore readline, looking like this with trun in it, call it trun.spk. Create a second file with the same stuff. You could just copy one file, and then all you have to do is replace trun with stats or stats with trun. All right. Okay, I'm gonna leave it up for just another 10 to 15 seconds. I'm gonna grab a drink and then we'll get the show on the road. And yes, there are videos on YouTube. If you're looking for the latest and greatest, there's a Buffer Overflows Made Easy 2022 edition, very recent. There's also older buffer overflow lessons as well, but the newer ones cover Python 2 and Python 3. Today, we're just going to be covering Python 3. All right. So, with this, what we're going to do is we're going to now run a spike command. So, we're going to say generic send TCP. And let me actually, before I even do this, let me just show you why we're doing what we're doing. So if we run generic send TCP, this is the command that's going to take the spike file or spike script. All right. So we're going to run it with our host. So that's our IP address. We're going to provide it a port, which we know. So we know both these things. We have our spike script and then the skip var, skip string. We're not going to worry about that. We're just going to leave that to the default of 0. All right. We come in here, and what we're going to do is we're going to run this generic send. We're going to give it all this data here, provide your IP address, provide your port, and we're going to start with the stats.spike. Okay. So it should look something like this. Whatever your IP address is, 9999 stats.spike 00. Okay. And we're going to hit enter. I'm trying to go as slow as possible, but also get this done in an hour, chat. So this is on YouTube. This is in the PEH course. Go ahead and hit enter. And you're going to see it's just sending out a bunch of data. And actually, if we go look at our data here, we can see that it's coming through. We can see that we're getting a bunch of connections, it's closing connections out. We're getting some receiving errors. Nothing really great's happening here. So we haven't crashed the program by any means. I'm going to go ahead and just hit Control C. So you can see that it's changing the variable size depending on when it sends it. It's not always the same size. It's not always in the same order. So it just goes and sends random fuzzes at this command. So it's trying to run the stats command here, and the stats command is not vulnerable to this buffer overflow spike. All right, so we're going to do a T run instead. And we're going to run our T run on this, and you're going to see that we've actually had a crash. So if you look at the bottom right, it's yellow. It says pause down here, right? So we're paused. You could see when we come through here, I'm actually going to just Control C because we're just sending a bunch of data for no reason. When we come in here, we see, okay, we ran the T run command, and let me see if I did this right. How's this look? Hey, look at that. Okay, so we've run the T run command. You can see we get a forward slash, a period, a colon, a forward slash. That's important for when we start building out our exploit. After this is run, we get these bunch of A's that come through. We see the stack pointer right here, the ESP, bunch of A's come through. All right. We come through here. We have the base pointer 41414141. Guess what? That's a bunch of A's as well. We get the EIP 41414141. This is also just a bunch of A's. This is just in a different format. 41 is equal to A. Okay. So what have we done? We've gone over the stack pointer, over the base pointer, over the EIP with all of our A's. We've sent so many A's that it overwrote everything. It crashed the program, caused it to pause. Got it? Okay, so we're going to go ahead and close down. Let me come back to the screen. We're going to close down immunity, which is going to close down our crashed vuln server. And we're going to come in and we're going to run immunity again as administrator. We're going to load up vuln server again. So you're just going to go file. You can actually go into your previously used, which is right here. and just load Vuln server, it'll automatically load it. And then all you have to do is hit play. Make sure you're doing that. So now we're running a new instance of Vuln server. Okay, so going to our Kali machine here, we're going to start writing some code for this. So the first thing that we're going to do is we're going to write a fuzzing script. So we sent a bunch of A's. We know it can crash the server, but we don't really know where we're crashing the server. We want to know how many bytes it takes to crash the server. This will help us when we start building out our shell code and we start building out our exploit. So we're going to see where do we crash the server at? A general ballpark. It doesn't have to be perfect. All right. So what we're going to do is we're going to do sudo mousepad. We're going to call it 1.py. This is our first step. Okay. And in here, I'm going to build out the code. So we're going to give it a user bin Python 3 and save that so it's pretty colorful. All right. And in here, we're going to go ahead and do import sys and socket. These should not be unfamiliar to you. You should be aware. And from time, import sleep. We've used both of these in the past in our Python lesson. So look at everything's coming back around full circle. So we're going to set a variable of buffer equal to a times 100. Okay, so we're going to send iterations of buffer in 100. Now, what we're going to do is we're going to say, while true, we're going to try. And here we're going to make our connection attempt. So we're going to say s is equal to socket.socket. Just like before, we're going out and doing what? Socket.afinet, which is our IPv4 address, and socket.sockstream, which is our port. Nothing new here. We're going to say s.connect. And we could put variables in here. Instead, we could define a variable up here of like IP is equal to. We could also build this out to supply a variable or supply an argument with argparse, or just give arguments in general. And we could do that and just say, hey, argument 1's our IP address, argument 2 is our port. And then we don't ever have to hard code this. Some ideas to maybe make a fuzzing script in the future without having to make it very specific to this. All right. So you come in here, do this, my IP address and my port inside of our tuple. We're going to set our payload equal to the trun command because we found that to be vulnerable. And remember, we saw this kind of format when we went in and we were looking in immunity. So we're going to give that as well. And then we're going to say plus buffer. And I'm going to walk through all this code and what it means here in a second. We're going to send this payload out in a payload encode because in Python 3, we have to encode our payload. S.close, and we're going to sleep for a second and say buffer is bugger. Yes, bugger. Buffer is equal to buffer plus a times 100. All right, so if we have an exception, meaning we can't get connected or it breaks, we're going to say something like print. Sorry, no F strings here. Fuzzing crashed at %s bytes. And then we're going to give it a string with the length of buffer. All right. And we're going to sys exit so we exit cleanly. All right. So here's what we're going to do. We've got buffer of 100, right? We've got 100 A's sitting in buffer. While true, so we're doing a while loop. We cover these back in Python. We're going to try something. So what this means is while we have a connection, while true, we're going to try to connect to this IP address at this port. We're going to send over a payload of this plus 100 A's. Okay, we're going to send that over. We're going to close out the connection. We're going to sleep for a second. And then we're going to add or iterate and make buffer another 100. So we're going to make it 200. Then we're going to repeat this process. It's going to be 200, then 300, then 400 until it crashes the server. Once it crashes the server, it'll say fuzzing crashed at, and then it'll give us the length of buffer when we crash the server. All right. So let's go ahead and save this and we're going to run it. Let's exit out and we're going to just say Python 1.py and let's make sure, triple check, make sure everything's still running. We're running over here. We're doing great. Perfect. Okay, we're going to come in here and we're going to Python 1.py. I'm going to hit enter and then I'm going to go ahead and immediately come over here and just watch. So you're going to see connections coming through, keeps coming through. As soon as this pauses, just in case, I'm going to hit Control C on my end. So I'm just waiting for the yellow down here to show up. Hopefully it will show up. Okay, we paused. We just broke the application. I'm going to hit Control C. Looks like our fuzzing crashed at 2400 bytes. Eventually this would have shown up and just crashed on its own. But for now, we lost connection. We destroyed the program. It's paused. And we broke it at 2400 bytes. All right. So I'm going to close this out. I'm going to get immunity reopened. We'll talk about next steps and why we just did what we did. So let's reopen immunity as administrator. Okay. And we're going to attach vulnserver.exe. Run that. Same steps. Repeat the process. Okay. So we figured out that we crashed the server at 2400 bytes. Why do we care? Well, we want to know the minimum it takes to crash the server. That tells us our working buffer space is 2400 bytes or less. So now when we're doing exploit development, we're trying to get within a certain space. We need to make sure that when we generate shellcode and do this, we need to stay within that 2400 byte area. And that'll become more apparent as we go through this process. Now, what we need to do is figure out where the EIP is. Remember, we're looking for that instruction pointer because we want to control that instruction pointer. So in order to figure out where the EIP is, we can write or we can generate code. Instead of sending a bunch of A's, we can send 2400 bytes of code that is distinct and unique, and then figure out where in that code is the EIP getting overwritten. Then we know a specific size and bytes to send over. Okay, so might not make sense yet, but it's going to make sense here in just a second. So we're going to do a user share Metasploit framework, and we're going to do a pattern create of 2400. All right. Now I'm going to leave this up for you to see really quick. So user share Metasploit framework. You can auto tab a lot of this out. Tools exploit pattern underscore create. And I'll even paste this in the chat really quick, just in case you get behind. I'm going to put this in chat. All right. So with that in mind, we've got this. We're going to run it, and we're going to give it a length of 2400 because that's where we crashed at. All right. What this is going to do is generate cyclical data here, cyclical bytes, right? AA0, AA1, AA2. We're going to send this over, and we're going to find out where these come through. Okay. So it might come through like right here in this little area, and we're going to see that when we send it over. We're going to use the pattern offset to figure out specifically where that happens. All right. So we're going to copy this data. And what I want you to do is I want you to go ahead and just copy 1.py to 2.py. That way you still have your scripts as we go, and as we build these steps out, you kind of understand the process. All right. So now what we're going to do is we're going to mousepad 2.py, not mousepad 2.py. And in here, instead of calling this buffer, we're going to call this offset. Okay. And we're going to get rid of this while loop because we don't need the while loop anymore. And if you highlight all this data right here from 9 to 20 and you hit Shift Tab, boom, look at that. It will automatically shift everything to the left for you. So, neat little trick. If you didn't know that, now you do. In the offset, we're going to go ahead and just put quotes around this and we're going to paste in here. And it's going to look something like this. So, here is very long cyclical value again that we're creating an offset. And we're going to come in here. We're going to try this. We're going to send the payload of trun plus the offset this time around. We do not need the sleep command. We do not need the buffer command. We can delete those. And we don't need to know where our fuzzing crashed, but we do need to know, say, as an exception, if we can't get connected to the server. So we might say error connecting to the server, something like that, right? All right. So we've got offset equal to the value we generated. We're going to try to connect. We're going to send that payload over with the offset. We're going to encode that payload when we send it over. If we don't make a connection, we're just going to get an error back connecting to the server. Okay. So let's go ahead and save this. Again, we're going to double check, make sure that we are running on our end. Make sure we're still up and running. We are. Great. Come back. And we're going to close this. And now we're going to run Python 2.py. Hopefully we've crashed the server again. We did. Let's take a look at the data that we see here. So what are we pulling down? We're pulling down this information of where the EIP was overwritten. Remember, we want to know where the EIP is so we can control this instruction pointer. This is our instruction pointer. We want to get malicious with it. So what happens is we overwrote at 386F4337. That's important to us. We want to know where that happened. So what we're going to do now is we're going to come back and we're going to generate. So we come back into here. We're going to use the Metasploit framework pattern offset. So if we do user share, and instead of doing pattern create, we're going to do pattern offset. And we're going to do a length of not even 3,000. We're going to do 2,400. We don't need 3,000. We generated 2,400, so we're going to do length of that. Then we're going to do a dash Q of what was seen in the EIP, that 386F4337. I'm going to go ahead and send this in chat as well. All right. So I'm going to give you guys a second. I'm going to take another drink. Second to get through this and find the offset. All right. I'm going to hit enter now. We found an exact match at 2003. 2003 is where our EIP is at. All right. So now we're going to test that out. We're going to make sure that what this program is telling us is the truth. We want to make sure that we can control the EIP. So in order to do that, let's go ahead and just copy 2.py to 3.py. Let's go back to our server and let's go ahead and close out of immunity. We're going to open immunity as admin again. You could just detach, by the way, but I like doing the closeout method and then just opening Vuln server and playing it again. All right, so let's go ahead and mousepad 3.py. We're going to get rid of this offset because we don't need it anymore. All right. Who needs the offset? Okay. So within here, now we can say something like shellcode is equal to A times 2003. Why? Because we know that the EIP starts right after 2003 bytes. So to test that, we can give it B times 4. So we could say, hey, we've got A times 2003. And then when we overwrite the EIP, we should see 4 Bs in there. So we should see 42424242 instead of all 4 ones, which are As. So in this instance, we're going to come in here and we're going to replace offset with shellcode. The rest honestly looks good. This is a quick swap, so we should just be able to save this. Again, shellcode is equal to, and I'll paste this in chat as well, in case you need to follow along. All right, do that. And then we're going to go ahead and do a Python 3.py, run it, and we have crashed the server. Not only have we crashed the server, our EIP is overwritten with 42424242. We sent 4 Bs. Bs are 42. Okay. A's are 41, B's 42, C's 43, so forth. Here we see 42424242. We now control the EIP. We now control the instruction pointer, meaning we can now point to malicious code and have that do something for us. So this is what's going to happen. We're going to go ahead. I'm going to come back to screen, and then I'm going to close out of immunity one more time. And now we can do a few things. So let's run immunity as administrator. What we need to do now is we need to do two different things. First of all, we need to find out if there's any bad characters within the immunity program. And what I mean about bad characters is I mean that if we have a situation where like 00, for example, the null byte 00, that will in programs cause issues if it's left behind. So if we leave 00 in our shell code when we're generating it, that's going to leave issues. Something like X25, I believe, is another one that causes issues. So there's certain things within or certain characters within shellcode that will cause issues within your specific program. It's all program dependent. And this program, fortunately, doesn't have any bad characters for us, minus the null byte. But I'm going to show you what a bad character looks like anyway and what to look for. And I'm going to show you two different ways to find bad characters. Okay. So we've got a lot of backseat exploit developers today in the chat. Anyway, um, so let's go ahead and take a look at this. So, two things that we can do. First thing that we can do is we can send over a bunch of bad characters and see what happens. So let's go ahead and copy, or we can send over a bunch of characters and see what happens. So let's copy 3.py to 4.py. And we're going to go ahead and gedit, or sorry, not gedit. That's old school thinking. We're going to go ahead and mousepad 4.py. And from within here, we're going to change up our code a little bit. So one thing that you can do is you can go out to YouTube, you can go out to Google and just Google bad characters. You can just say, hey, bad chars, GitHub, something along those lines. And you should be brought to this Sitopia bad chars. I'm going to go ahead and paste this in chat as well. I might paste this in chat by pasting the right place. I no longer gedit because they removed it from Kali. So I just use mousepad. It's a lot easier. I love gedit, don't get me wrong. So within here, what this program does is it generates bad characters for you. But we can actually just copy the bad characters that are from within. So we don't even have to download the program and generate it. But it will generate them for different types of programs. So like Python, Ruby, etc. Different types of programming languages, I should say. So we can come in here, we could just copy that and just paste the bad characters in here. All right. So for some reason, when we send over our bad characters, I think we ran into some issues with the payload encode, or at least I did yesterday when I was practicing this. So what I'm going to do instead is instead of doing a payload down here, I'm actually just going to encode this, or we're just going to send this without encoding. So I'm going to say s.send, and we're going to do trun plus bad chars, bad characters. Actually, no, plus shellcode. I lied to you. I'm sorry. We're going to keep the shellcode. I don't know why I deleted it. Don't listen to me. Bad influence. So shellcode again was equal to A times 2003 plus B times 4. And then we just add in the bad characters because we're trying to see where they go into the stack. Okay, so before I send this off, this is one place to look for bad characters, or one way to look for bad characters. I'm going to save this. Two more places that we can do this. First of all, one cool thing that we can do is we can generate bad characters with Mona. All right. So if we want to, we can take a look at that. Let's go ahead and set a working config for Mona. If I can find it. Actually, I might not have my notes on that. We can set that. I'll put that in the notes in the chat. I'm not seeing it in mine. I do see the byte array compare though. All right, so let's go ahead and send this off. Give me 1 second. So we got this running. We are pause. Let's hit play. Did we crash this? No, I don't think so. No. Okay. So let's go ahead and do this. And I'll paste this video or put the Python video for Python 3 on our academy, the live academy. So we've got this saved. We got the bad characters. Let's go ahead and send this. I'm just making sure it's correct. All right, I'm gonna save it and send it. All right, now Python 4.py. Run that. See if we're paused over here. We are paused. So a couple things happen. First of all, we go to the right side. Okay, we've got our EIP overwritten with 42424242. Now we want to look for bad characters. And in order to do that, we need to right click on the ESP or the stack pointer, and we're going to say follow in dump. Okay, and that's going to actually go to, if I show you the screen, that's going to go to this lower section right here. And I'm going to go ahead and bring that up. And this is what it looks like in the hex dump. We're looking at all the characters 01 through FF, I believe. And so we started 01, and literally the eyeball test is saying, okay, 01, 02, 03, 04, 05, 06, 07, 08. Is anything missing in that? No. 09, then it goes 0A, B, C, D, E, F, 10, 11, 12, all the way down until we get to FF down here. We want to know if there's anything missing. So a good way to check that, I'm going to show you with PowerPoint just what that looks like. So in PowerPoint, here's a list of the bad characters that we have here. All right, we have this list of trying to find bad characters. This is what Vuln server's output looks like. My screen is black. I'm sorry. 1 second. All right, that's better. Okay, so here we go. We've got the finding bad characters section. And then this is what Vuln server looks like. Now, if we want to take a look at another program that has bad characters, here's a better example. You see 01, 02, 03, B0, B0, 06, 07, 08. So we highlight those. And okay, we'll say, well, we know 04 is a bad character. We know 05 is a bad character. We know 28 is a bad character. We know 44, 45 is a bad character. We would go through this whole process and write down all the bad characters that are here. Because when we generate our shellcode, we want to make sure that we do not include these bad characters in our list. We want to make for sure that these are not included, because if they are and it gets generated to the shellcode might not work. It might tell the program to do some instruction, and that might break the shellcode. All right. And somebody asked, "Is it always B0?" No. You're just looking at an oddity, something that's not right here is what we're looking for. All right. The B0 itself is legitimate. It's not highlighted. B0 itself is legitimate, or wherever B0 is. Sorry, I have it. I highlighted the wrong one. This is correct. This one is not legitimate. I deleted the wrong one. So, good catch. All right. So, with that in mind, let's go back. Let's go ahead and copy 4.py to 5.py. Now, there's one more thing we need to do. We need to do what's called finding the right module. And we need to come in here, and in order to find the right module, we need to look at Mona modules. So let's go ahead and take a look at that. Give me one sec to bring back immunity. So let's close immunity out completely, and let's open it one more time. You can actually use Mona to find bad characters. You can generate a byte array and then use that to compare against the bad characters list. So there's a instruction on that will be shown in the video. I don't have the syntax for generating the byte array. Otherwise, I have the rest. All right, so let's go ahead and attach this and hit play. Now, one thing we can do is we can come down here to the bottom. Let's test this out. I don't know if I actually got this right. Hey, all right. We can come down here and we can type in Mona modules. All right. So we come in here and we can see the modules. And what are we looking for? Well, we're looking for something that has no memory protection. So we're looking at ASLR, we're looking at safe SEH. We're trying to ideally see anything that says false across the board. Okay. And we're trying to tie that into our Vuln server. So you can see any of these things that say true when we're looking at these modules. Any trues we have, we really don't want to run with. But we do have this right here, this Mona module sitting on false, this essfunc.dll. All right. So we've got essfunc.dll, and we're going to go ahead and play off of knowing that. So what we want to do is, with knowing that the essfunc.dll is an appropriate or potentially appropriate module, we want to issue a jump instruction. So we can say something like a JMP, and we want to find the ESP register, right? We want to find the stack pointer. So this is going to be our jump instruction for our pointer. And we're going to say we want to look for a module of essfunc.dll. Hit enter. And that just did some wild stuff. Let's see if it works. There it goes. Okay. Let's minimize. I don't know why it's bringing that back up. Let's go back to screen. It's one of these here. I don't know my buttons that well, chat. Okay, let's try that one more time. See if it keeps it minimized. There we go. So right here in this screen, the log data, which is right here, we should see if I can make this bigger and put it in the right area. Let's drag this down to the bottom. Perfect. Okay. So it gives us address spaces that could be good for us to use. So, for example, we have this address space of 625011AF. We've got this other one. So what we would do is go down the list. We're looking at the different pointer instructions for our stack pointer right here. And it's finding these ones with essfunc.dll specifically. You can see there's no protections on them. So what we do is we start with the first pointer, the 625011AF. So we're going to notate that down. And I'm actually going to close. Let's bring up C, and then I'm going to capitalize that, or maximize that, I should say. I'm going to close immunity, and I'm going to reopen it one more time. Just make it nice and clean. Let me bring the screen back. Can we become a pen tester without buffer overflows? Yes, absolutely. All right, so let's open up Vuln server one more time. Get that running. Hit play. Now, what we're going to do is we're going to, up at the top, hit this. Let me see if this works. If I can bring that in. Sorry, wrong button. Okay, so not yet. Up at the top, there's a red arrow and a blue arrow. Go ahead and hit the red arrow, or the blue arrow, I'm sorry. Red pill, blue pill, right? So when we come up here, we're going to go ahead and say 625011AF. We're going to put that in the expression to follow. Hit OK. That's going to bring us to this JMP ESP, this jump pointer. That's exactly what we want. All right, we want this 625011AF. This is JMP ESP. We're going to go ahead and click on that, and we're going to hit F2 on our keyboards. It should highlight this left area blue. We are doing what is called a breakpoint. We are hitting a breakpoint in this. So what's going to happen is we're going to run malicious code against this, and we're going to point to this instruction here at 625011AF. If it hits that instruction, it's going to stop. It's going to stop the program and say, hey, breakpoint has been hit. Good job. We know for sure we hit a jump instruction with our EIP. So if we come back, let's go ahead and copy 4 to 5. All right, let's mousepad 5. And now we can get rid of the bad characters because we're not sending that over anymore. We can get rid of the bad characters right here. And we're going to modify our code just a little bit. So what we're going to do is we're going to put in our code, instead of the 4 Bs, we're now going to give it an instruction pointer. And we're going to call that XF, X11, X50, X62. Why? Well, we had what? We had 625011AF. Why are we putting it backwards? Well, we're doing what's called little endian, ENDIAN format. And basically, little endian stores low order byte at the lowest address level, and it stores high order bytes at the highest address level. That means when we put this in, we actually have to put the addressing in backwards. So we're trying to get to this address space within the code. We're trying to get to that JMP ESP instruction, so that way we can jump to our malicious code. With this and using Python, we're going to go ahead and byte encode these now. We're going to try this. I've tried byte encoding with the send payload encode. It didn't work very well for me. So make sure that you put B's in front of your trun command, in front of your A's, and in front of your memory address here. This is an AF. You're correct. We are missing an AF here. Good catch, guys. All right. So this is what the code looks like. We're going to go ahead and save this. We're going to run it. And hopefully we cause a breakpoint to happen. Okay. You can see that we have pause down at the bottom. It actually says, hey, breakpoint, step into to press F7 to step into. If we look at the EIP instruction here, you can come in here and you can see, hey, look, ESS func at 625011AF. It's ready to point to the next or jump to the next instruction. Okay. We've hit our breakpoint. We are ready to add malicious code and make this work out for us. All right. We are at the finish line, chat, the finish line. So much so that we don't even need immunity anymore. I think we've got everything that we need. So let's go ahead and run Vuln server as administrator. All right. Let me bring my screen back. All right. And what we're going to do is go back to our code. We're going to copy 5.py into 6.py. And now we need to generate some shellcode. All right, this is the last part. So we're going to generate shellcode, and what we're going to do is we're going to use a tool called MSF Venom. I'm going to auto tab this, but I'm going to walk through everything that I'm talking through, just so I don't have to type it. Okay, so the -p is a payload. Remember, we talked about different types of payloads that we can send in the last lesson on Wednesday. So we've got a Windows shell reverse TCP. What is this? Is this staged or non-staged? It is non-staged. You are correct. Good job. All right. The L host should look familiar. That is our listening host. I am on 192.168.138.140. All right, we've got an L port of 4444. You could set this to whatever you want it to be. We're using a file type of C, though you could use a file type of Python if you wanted to. The architecture of this is going to be x86. Even though we are attacking a 64-bit machine, this program is actually written in 32, and we're attacking in 32-bit architecture. So make sure that you're using x86. And then the dash B, bad characters. All we have is the 00. We have the null byte. That's it. Nothing else. This is where we would add bad characters. If we had like a 01, we'd come in here and just say X01, X02, whatever the bad character would be. We'd come in here and add that. But in this instance, we just have the 00. So we're going to go ahead and just hit enter here. And this is going to generate shellcode. So for those of you saying this is your first time, if your first time going through buffer overflow, this is complicated. It's not that difficult once you understand it. It is complicated as a first time go. I will tell you that I skipped learning buffer overflows for a very long time. It was one of those things that I needed a lot of momentum to go back and learn. Once I did, I started teaching it to other people and trying to teach it on YouTube and to myself, and that really helped me understand it. So go through the YouTube videos, go through the course videos, make sure that you understand in detail what it is we're doing and why. And if you have any other questions outside of that, don't be afraid to ask those questions, or don't be afraid to go to Google if you feel like the questions weren't answered in the videos as well. Buffer overflows are hard. Stack based beginner overflows like this aren't that hard. All right. So we're going to go ahead in here and we're going to do a final size of 351 with the payload in size. So this is important to know. If we're within, remember, we have a 2400 byte space or so when that crash happens. We're sending 200 or 2003 bytes, plus we're sending 351 bytes. So we're getting really close to that 2400 marker. Okay, so there may be a time where we try to like size this down or encode this differently, so that way the file size is different. But we have enough room to squeak in and be fine. So we're gonna do that. So I'm gonna go ahead and copy this, and this is okay. Let's go ahead and put this into our file. So if we go and do mousepad 6.py, we're gonna come in here. We've got our shell code. We're gonna call this now overflow is equal to, and then you just put a bracket on the outside or a parentheses on the outside, parentheses on the inside. You just paste it just like this. Now, the one annoying thing is we need to byte encode this, and we're going to put a byte in front of every line or a B in front of every line. There is a way to payload encode this, although the way that I was attempting last night for some reason wasn't working. It had worked in the past. So I'm just going to take this method and just put B's in front of everything. It takes an extra 10 seconds. Not a big deal. Okay, so we're going to put the B's in front of that. And then all we're going to do is add in here our overflow. On top of which, we're going to add what is called a no operation. All right. No operation, or what's called a NOP. If you've ever heard of NOP sled as an example, that's what we're doing. And all a no operation is padding. So if we come in here, we can do something like x90, which is a NOP, times 32, and do plus overflow. What are we doing? Well, we're adding padding here. We don't want, for instance, the overflow to interact or interfere with whatever's going on right here. There's a small chance that that actually happens. We can byte encode this, by the way. There's a small chance that happens. So we add a little bit of padding in between, and then we send the overflow in. So we've got 2003 plus 4 is 2007 plus 32 is what, 2039 plus 351 is 2340 or 2390, right? So we're still within that 2400 crash space as well. All right. So we've got this put in here, got this set up. Everything looks okay to me. I'm going to go ahead and save this, close out, we're going to open a new tab. We need to have a reverse shell listener. Okay. Remember, we did a reverse shell last time. Same thing. This time we're actually listening and we're going to catch it on our own. All right. And we're going to try Python 6.py. Hopefully I didn't screw it up. Hey, look what happened. We got a shell. So we come in here, we can say, who am I? We're running this as administrator, host name, the Punisher. Perfect. And that is how you do a buffer overflow. This is a very basic stack-based buffer overflow. I probably melted your mind today a little bit. I'm sorry. Could we have gone a little bit slower? Yes, but we took literally the full hour for this. So literally the full hour. And it looks like we just got Windows Defendered. It shut us down. Beautiful. Looks like we hit the hour time limit on the VM and it shut me down. So that's fine too. All right. This is probably as hard as the course is going to get from a I don't want to say that. Everybody learns differently, but this is probably as technical as it's going to get from this kind of standpoint. There's other techniques and tactics and stuff that we're going to talk about that could be difficult, but this is, one of the harder things in my opinion as a beginner to kind of overcome. All right, I'm going to come back to screen. I'm going to take a drink. My hair's somehow gone crazy since we all started. My hair's all standing up on the sides. Feel like a mad scientist. All right, so buffer overflows on pen tests. Good question. Uh you're never, unless something crazy happens, you're never going to do a buffer overflow exploit development on a pen test. Now, if you are doing research or exploit development research and you have a client that wants you to look for that kind of stuff, that's a little different. But on a pen test, chances of you doing this are zero. Now, that doesn't mean you can't run a buffer overflow on a pen test, but you're not 0 day coding an exploit on a pen test. So that makes sense. Yeah, that Windows VM that I just ran is very old. The license expired on it. I'm pretty sure Windows shuts down the machine after an hour because the license is expired. So we got just an hour of usage out of it. Any more resources for the videos that you mentioned? So there are boxes on Try Hack Me that was mentioned. Corlan has Corelan has buffer overflow resources. Um, God, there's a lot of information out there on exploit development, though I wouldn't say there's a good course on exploit development. There's some okay courses on exploit development, but nothing that I would say is worth the money outside of getting into like sans territory, which is expensive. There's some boutique exploit development courses that are out there that are like 3 to 4 grand as well. So it's a kind of expensive to break into, but there's a lot of resources out there. You just kind of have to piece together your own information, if that makes sense. Is that a sugar-free Powerade? Hey, it is a Powerade zero sugar, zero sugar. Because I know you guys care so much. You could test the bad characters. Well, no, you do have to control the EIP. So, look, you go through the EIP and then you cut down into the stack pointer. Understanding and following the stack pointer is that next set of instructions. So you have to get to that area where you control the EIP, and then send the next set of instructions, which is your bad characters, which are your bad characters. So yeah, you do actually have to do it right after the IP. How do you identify if a system is vulnerable to buffer overflow? If we're talking a known buffer overflow, it would be through vulnerability scanning and looking at and doing enumeration on the ports and services that are running. If we're talking about developing your own exploit, you're not going to do that against the system. You're more likely going to find the software. Like, say you had vuln server software and you're running that on your computer, and you're like, hey, I wonder if this is vulnerable. You would go through a lot of the steps, though today is very basic in terms of exploit development, it's basic. You would go through that same kind of procedure of trying to figure out, hey, what can crash this program? What's vulnerable here? And then how do I build upon that? Can buffer overflows be used in web apps? Yes, there are buffer overflows in web apps as well. Um, they exist in bug bounties. You would have to look up bug bounty write ups, but I feel like those are very niche cases. What is next week going to be about? That's a great question. I'm not sure how I want to take the direction of this class yet. This is kind of the first stopping point of where I wanted to get. I think next week we're either going to start focusing on privilege escalation, or we're going to start looking at the capstone machines and then get into privilege escalation. I just don't know which way I want to take that. I think we might go into capstone machines and spend a week or two there, and then get into priv. If a program crashes, does that mean it's vulnerable to buffer overflow? I would say not always, but it would mean that it's vulnerable to a denial of service. If you're crashing it, obviously you're doing something that wasn't intended in breaking it. So there's a minimum of denial of service. Whether you can turn that into a reverse shell is to be seen. Uh, is it a favorite of a majority of hackers? I don't know if it's a favorite. I just think it's something that, like, it's one of those stepping stones that you go through as becoming a hacker, is kind of learning the basics. Whether you expand on that is kind of up to you. So I never chose to expand beyond like some very basic stack overflows. It's never really needed for my work. So I kind of like teaching the introduction or introductory period of it, but in terms of like more exploit development, I don't need it for my career. And unless you go down that route, you might not need it for your career either, unless you're going in, you're doing it for CTFs or doing it for fun and learning practices. Why do you not need to do a buffer overflow in a pen test? You mentioned this, but I didn't really get it. All right. So think about a pen test. A pen test is a timed engagement. You've got a week. If you find software and you say, "Hey, I'm going to go download this software locally and try to write a 0-day exploit for this," do we think that that's the best usage of your time? Probably not. If that's something that you can do in your downtime, your free time, you want to work on finding CVEs and vulnerabilities and writing code, more power to you. Is that the best usage of your time on a pen test? No, definitely not. Is reverse engineering and buffer overflows correlated? Yes, they're correlated. Are they the exact same thing? No, but do they go hand in hand? Yeah, kind of. How much of what I'm covering as of today, this lesson, this is all on YouTube. You can go find it on YouTube. Is it in the PEH course? Yeah. But we also have it on YouTube. I don't know if I think the Python 3 materials also, like what we covered today was all in Python 3. I think there's Python 3 on YouTube as well, but there's definitely Python 3 in the course. There are no student discounts for TCM security courses. We have student discounts for the PMPT and the PMPT with training. That's all we've got student discounts for. Same thing with military, same thing with first responders, and educators as well. We run discounts once a quarter, so if you're looking for a specific course discount, that would be the time to do it. Do we need the specific Windows VM that we use today? No, you can delete this Windows VM. Yes, next week is going to be live. We're not stopping the show for DEF CON, unfortunately. So, would be learning assembly language and hex codes be beneficial for buffer overflows? Yeah, for sure, 100%. Do interviewers ask about buffer overflows? I've never been asked about one in an interview. It doesn't mean that it wouldn't happen. I think it depends on the job. If we're talking pen test interview, maybe. I don't see the purpose or the need. Um, so I mean, I guess it just depends on the interviewers. Some interviews go like the trivia route, which I really don't appreciate. So it's hard to say, but I would say more likely than not, you shouldn't be asked about it, but it doesn't mean that you wouldn't be asked about it. When or if you update the course, does it affect the exam or is the exam fixed? The exam is partially fixed. The exam's always changing. Um, our goal here in the next 6 months is to have rotating exams. So anything that's in the course would be in the exam or be available to be in the exam. If there's an instance where something latest and greatest shows up and we think that the material's outdated or the exam's outdated, of course we're going to change the exam. As of right now, we don't feel that way. I feel like the exam is pretty representative of an official or a realistic pen test. TCM courses cannot be purchased on installments. Um, PMPT can be purchased on installments. So if you get the training with that, then yeah, you can get some of our courses on installments. But from the academy itself, no, it can't. And that's more of a limitation of the academy than it is our end, honestly. I can't say much about new TCM security certifications. I can just say that we have goals to have two more out by March of next year. And I think that's a realistic goal. Once our exam platform's built, there's a certification in the pipeline that I would say we could probably have spun up in a week or so. But when doing an internal pen testing, how do clients give you access? Remote into a machine with standard privileges on site, send your own device. Yeah, it's a variety mix, right? The majority allow us to send a device that we have. And that device is a Windows machine. It's not going to be domain joined. So it's almost like if we were on site and we plugged in a rogue device. And then we just kind of go from there. Um, Sometimes we've been provisioned a machine. Sometimes clients will say, "Hey, I want to do an assume breach." So we're going to give you access to remote access to a machine on our network, and we're going to see where you can get with that machine on our network. It's going to be just like an employee was set up, and we're going to see how far you can take that. Um, can we do internal pen tests on site? Yes, though we're a remote workforce and we don't travel unless we absolutely need to. There's no point in traveling, in my opinion, unless we're doing a physical pen test. Or if the pen test is internal, then the network should be air gapped, unless there's some sort of compliance or something driving to be on site. But there's no real purpose for that. The only other thing I can think of is clients will generate a VDI or virtual environment for us, and we can use that to do pen testing as well. But majority of the time, we're just shipping a laptop out. Would the PMPT certificate be lifetime or do it need to be renewed? We have no maintenance at this time. We have no renewal process at this time. Currently, it's lifetime. There are a lot of regulations and stuff out there or regulatory boards and order to get the certification certified, you have to expire it, and we fought back on that process so far. Thank you for all the subs that have come through, by the way. I've seen a ton come through today, and Matt Bogenberger just gave 10 more gift subs. So thank you very much, Matt. Appreciate it. You're always giving out subs. And hey, you are in the lead now. 65 gifted subs lifetime. Thank you so much, man. Appreciate it. Looks like we hit the bottom of our questions. So we can end Friday early if we need to. We can go ahead and let's try to find somebody to raid, maybe. Anybody has suggestions? Why do we set a breakpoint? Because we want to make sure we're hitting that breakpoint on the JMP ESP. We don't want to go past that. So we'll make sure that it catches and that we're actually controlling that JMP ESP to point to the next instructions. Uh, beer time? No, it is clean the axolotl tank time. So I don't know what I'm going to be talking about yet at B sides. I'm going to be meeting people for sure. Yeah, that's the point of coming in person is so that you can meet everybody. If I'm being honest with you, I have the ability to talk about whatever I want since it's keynote. I have no idea what I'm so passionate and fired up about today that I'm going to be wanting to talk about in 2 months. So we'll see when I get there. I have thought about making an axolotl cam. I have not. I think I've got a. I would have to do it with a wireless cam. The only wireless cam I have is a GoPro. I'd have to see if I can get it set up. And I have one or two pictures of the axolotl on my Instagram currently. What glasses do I have? I can tell you if you give me just a second. This is I got these from Glasses USA. They were a sponsor a long time ago, but I kind of just liked the glasses. So let me see if I can find the frame specifically that I ordered. I got let's see. These are called Muse M Classic Matte Black. I'll type that in chat. Muse M Classic Matte Black. That's from Glasses USA. Sadly, no affiliate code there. So the axolotl likes to hide. He either spends his days lately in his cave, or he spends it at the very top of the tank on top of one of the plants that we have. For some reason, for the first week that we had him, he just kind of was like in corners and like kind of hiding behind different things. But now he's become more comfortable and he just like he's got his spots that he likes to hang out in. He's more of a night owl. He likes to kind of come out at night. Yes, hide or playing dead because he did scare me. Although I'm getting more used to his tactics. So it's just hard because they don't have eyelids. So you don't know when they're sleeping. You don't know like if they're alive. It's you just kind of have to feel them out. All right, we're rating, guys. It's been a pleasure. I'll see you next week.